Hello everyone, welcome again to my channel. So today we will discuss one LeetCode problem 1386, that is cinema seat allocation. So what is the problem statement here? The problem statement is we have a cinema hall and there we have row wise seats. One particular row have 3 seats, then 4 seats, then again 3 seats. Means in between 3 seats and 4 seats we have a gap. Okay. So now what is the end result we want? The end result is few seats will be blocked and that seats number will be given to us. We have to adjust a family of 4 members here. And how this member of 4 will adjust here? The thing is either they can sit from 4 to 7 continuously or 2 to 3 and then 4 to 5 like this way, or 6 to 7 and 8 to 9. So family of 4 can sit only in 3 combination. One is from 4 to 7 or from 2 to 5 or from 6 to 9. So what you will get as input is number of rows. Suppose how many rows are there. So here if you see 3 rows are there, and what you will get is reserved seats, means which seat is already reserved. So 1, 2 means for row 1 the seat 2 is blocked. 1, 3 means in row 1 the seat 3 is blocked. And similar fashion for the other one. Now you have to determine like how many families you can fit here. So from the row 1 you can see only one family can fit in because they can't sit here or here. And for row 2 they can only sit here. They can't sit here or here. For row 3 they can either occupy this part or this part, means total 2 combination is possible. So one thing is clear that 3 combinations we can use, but at max 2 combinations only we can use. Means in a particular row max 2 family group can sit. Now just talk about few constraint here. So the number of n means the number of row can be from 1 to 10 to the power 9. And this reserved set length also can be 1 to minimum of 10 to the power n or comma 10 to the power 4. So what we can see from here is the number of row or the reserved seat array can be a big length array or the big length number. So we have to keep that thing in mind. Now what is the first brute force approach we can take to solve this problem? So the first thing is we can define a variable called count family. That will be our final result. Then, and we can initialize it to 0. Then we can traverse from 1 to n, means from 1 to number of rows. And for a particular row, if we have to talk about the result, then what we need? We need all the booked seat in that particular row. So we already have a reserved seats array. So from there, for this particular row, we can take all the booked seats. So we have to scan entire reserved seats array and we have to get the booked seat for that particular row. One thing to mention here is this reserved seats array is not sorted. Means 1, 2, then the next input can also get at the end of the array, maybe 1, 5. So you have to scan through the entire array to get all the seats booked for row 1. So now in this case, if we scan through the reserved seat array, then for row 1, we will get 1, 2, 1, 3 and 1, 8. These 3 seats are already occupied. So you can see from this picture also, 2, 3 and 8 is blocked. So then what we have to do is, this is the seat and we have to book this 2 here, then 3 here, then 8 here. And after that we have to apply some logic. What logic we can apply is, if these seats are booked, then what is the possibility? So from here what we can see is 2 and 3 is blocked. That means here we can't adjust. From 2 to 5 there is no chance of adjusting. 8 is blocked. That means from 6 to 9 one family can't occupy. 4 to 7 there is a chance. So that's why For this combination only one family can sit. So we have to apply logic to get the count and add it with the count family, because we are traversing row wise. So for that particular row, whatever result we are getting, we will add that thing with the main count family variable. So here we got this one as a result. So we will update the count as 1. So what we noticed here is, what will be the time complexity here? So we are first traversing row wise from 1 to n. Then for that particular row, we are fetching all the reserved seats. For that purpose, we have to traverse to the entire array because it is not sorted. Then when we are getting the booked seat, we are applying some logic on this to get the exact number, and then we are updating. So it is taking O n square of time, or you can say O n into the length of this reserved seats array. So now we will check if we can do something better. But before that, what we noticed that I will go through. The thing we noticed here is, if no seats are blocked, suppose we got a row and for there no entry is present in the reserved seats array. That means no seats are booked for that row. So for that row we can consider 2 family, because at max 2 family can occupy. Or else if seat number 1 and seat number 10 is blocked, and apart from that all the seats are empty, then also maximum 2 family can sit, because either one non-blocked row or 1 and 10 blocked, both are similar, because 1 and 10 is not playing any role here. So if no seats are blocked for a row, or seats 1 and 10 are blocked, then 2 family can accommodate. So this thing we have to consider. So before moving to the better solution, one thing to consider here is, if you do it in O(n) square time using brute force approach, and if you submit the code in LeetCode, you will get a time limit exceeded error. So we have to try to do it in O(n) time. Now we have to check, is it necessary to traverse every row and then for that row every reserved seats? So what is preventing us here? Because for a particular row we don't know all the reserved seats. That's why for that row we can't get into a decision. But instead of that, if we reserve seats array, if we completely traverse, and for a seat if we can come up with some decision, then and there we can block or unblock that particular area. Suppose scan entire reserved seats array and then think from that background. Suppose if you see here, other than taking consideration all the seats, if you think that 3 combination is possible, one is the left side, one is the middle one, or the right side. So here take one example. Suppose whenever I am traversing this reserved seats array, suppose I traverse this one, then my row number is 1 here. So for that row, create one map kind of thing, where the map key will be an integer, that is the row number, and the value will be a boolean array of 3 fields, left, middle and right. So the map will be of integer boolean type. Okay. Now what we got? We got the first value as 1. So if 1 is already not present there in the map, then just put 1 here. And by default, left, middle and right will be true here. So what we will consider here is, we will check which seat is blocked. So here seat number 2 is blocked. Now we have to tell here that if seat number 2 is blocked, then which of the following I can't access. So if seat 2 is blocked, that means left side part, this part I can't access. It will not affect the middle or right part, right? So because of 2, this particular thing will be false. Then if we consider about the second one, 1 comma 3. 1 comma 3 means this 3 is blocked. 3 is blocked. So which seat or which family group it can affect? As 3 is blocked, it can affect only the left part, right? Because 4 to 7 anyone can sit, or maybe 6 to 9 also anyone can sit. So as it is already false, nothing we have to do. Then we will check for 1 to 8. For 1 to 8, what we can see is 8 is this seat. So this seat, if it is booked, then where I can't consider the family members, that is only the right part, right? Like from here to here. Here no one can sit. So only this part I will make it as false. Now we will proceed. So the fourth number is 2 comma 6. So as 2 is a new row, then we will create a new entry in the map and we will maintain here as 2. Then which seat is blocked in the row 2? That is 6. 6 is blocked. As 6 is blocked, that means which among this I can't access? Obviously the middle one, because middle one no one can sit. So this is false. And from here to here, the right part also no one can sit. So this part is also false. Next we will go for 3 to 1. So here one thing to consider is, if seat number 1 is blocked, there is no effect of this seat, right? So we will skip, as I have mentioned in the earlier slide. Next is 3 comma 10. So seat number 10 is blocked, but for seat number 10 also there is no effect, right? So we will skip. So if you see here, for 3, no entry only we created. Okay. If for the later point of time we got an entry called 3 comma 5, then we can consider. But if we get seat number 1, seat number 10 is blocked, straight away we will skip that part. And for row number 4, there is no entry itself present here. And it is true also, because for 4, no seats are blocked. So we will not consider that one. So I just formed the map now. Iterated over the reserved seat completely and formed this map. Now we have to calculate the result. So now if we go and calculate the result, what we can see from here is, for this row, as left and right is blocked, then only middle is free. So here I can get only one family member. For 2, middle and right is blocked. So here also we can get only one family member. Now is our total result is 2, 1 plus 1? No. Total result will be, so in the map, the size of the map is 2. That means for this 2 row, we have blockage of seats and we are calculating. But total number of rows are 4, and 4 minus 2. Minus 2 means the length of the map, that is 2. So 4 minus 2 is 2. So for that 2, we can straight away consider 2 seats each. Because for 3 and 4, no seats created any effect, right? So maximum 2 family can sit there. So straight away for 3 and 4, you can consider 2 seats each. Okay. So here you can see one member, here also one family member, here straight away it is 2, here also 2. So total number of seats will be 2 plus 2, 4, 5 and 6. So 6 family member can sit here. So the formula to consider here is the total number of family member which can accommodate here is the result from the map. First you have to calculate the result from this map, which is 1 plus 1, 2. Then n minus map size into 2 to calculate the rest of the part. So I hope this part is clear now. And here in this case, what you saw is we are just traversing once in the reserved seed array, and then only we are getting the result. So the time complexity reduced to O(n). Now we will see the coding. Now coming to the solution part. So first we have to define one count variable where we can keep track of the counts, and then the boolean seed array, and the map where actually be a integer and boolean type of map. Now we have to iterate over this reserved set array. So it will be reserved set dot length plus plus. So here what we have to first consider is what is the row number. So the row number will be this reserved sets position of I comma 0. So this will be our row number for that run, and S will be our blocked seed, you can say. So this will be our blocked seed. Now, as we mentioned, if we check that the block seed, so this block seed, if it is 1 or 10, then we will just continue. If S equal to 1 or 10, then we will continue. No need to do anything. Or else what we can do is we can create one map for that row, and so what we can do is if that map already contains the row, then we will just simply take the seeds map array, okay, or else we can create a seeds map array, and we can initialize all the left, right and middle as true. Now we can apply one simple logic here. If S means the block seed is 2 or 3, then we can simply tell that the left seed you can take, means the left part you can take. Else if you check that S equal to 8 or S equal to 9, that time we can say that the rightmost seed in seeds right will be false, means that seed we can't take. Or else if like 4 and 5 is there, then means left side also we can't take, and the middle one also we can take. If it is 6 or 7, then right also we can't take and middle also we can take. So we will write that also. Okay, so if it is like 4 or 5, then left side or middle one we can take. If it is 6 or 7, then the middle one or the right side also we can take. Now as our logic is over, which will just tell that this particular seed can be given or not, then that result we can simply put it in the map row comma seeds. Okay, so now we will completely iterate over this reserved seeds array, and according to the logic it will check like if left side, right side or middle one, which one to block, and it will complete its part. Then next what we can do is we can write the logic for counting, means we have to iterate over this map. Okay, we have to iterate over this map, and this will be a seed available boolean array. So if we can say that that the left side is also available, the middle one is also available, and the right side also available, or left side and the right side is available only, then we can simply say two family can sit together. So we will increase the count as count plus 2. Or if 0 and 2 is like available, or only 0 or only 1 is available, that case also we can increase just the count to 1. And same is for if the 1 and 2 both are available and only 1 or 2 is available, that time also we will do a count plus plus. Okay, so you can also, in your own way also, you can write this logic, and maybe you can simplify this also, the counting logic. Then we are just iterating over the whole map, and at last what we will do is we have to get the final count. That will be count equal to count plus, we have to check like for which row there is no seat blocked, or 1 and 10 is only blocked. So that time the size of the map we have to minus from the number of rows, and we have to multiply it with 2. So this particular thing we have to add here. Then we have to return the count. Yeah. So now if we submit this, yeah. So that's it about this seat allocation problem. So one thing to talk here is this problem you can solve using bitwise operator also. So that is a better approach or solution, you can say. So I will try to make a separate video where I will talk about bitwise operator, then how to solve this problem using bitwise operator also. So as of now you can go with this problem and this solution, and I hope you enjoyed the video, and if you have any comment you can mention that thing in the comment section, and the GitHub link for this code also I will put it in the description box. Thanks for watching.